Okay, we're gonna do a very last very last motion. It's going to be a very parabolic motion. So everyone's played this awesome game, Angry Birds. Angry Birds is actually, in terms of a game, in most games these days, they try to capture reality as much as they can. So in order to actually make a lot of video games these days, you have to really understand the laws of physics in order to actually try to make a lot of motion real. So a lot of things like Angry Birds, you have to try to simulate gravity. You have to try to simulate how motion would actually act, um, depending on realistic values, realistic variables that you put in. So if you say, so in our top right over there, I've got a little bit of a video of me playing Angry Birds Rio. Awesome game. But let's solve this problem here. So if we had an Angry Bird and we launched that Angry Bird at 10 meters per second at 30 degrees from the horizontal, there's a couple of different questions that we want to answer. First of all, how long does it take for the Angry Bird to do its entire motion and land? So that's first, can I get rid of this and just get out of the motion? How long it actually takes. So here, put 10 meters per second. How long it takes for it to complete its motion. So let's say it's going to do something like that, and it's going to get to a point where it hits the ground. How long it takes to actually do that motion. So let's put its final time. How high is it? Well, how high is it at its maximum point, and how far does it actually get across? We can answer those couple of things. First off, remember, with any two-dimensional motion, we need to split them into their component motions, being the component in the vertical direction and the component in horizontal. So if we split them in the horizontal direction, we know that to the right is positive. In the vertical direction, we know that an upwards motion is a positive motion. So let's get it going. First off, we need to find out. Let's get a couple of different intuitive things. We know that the acceleration in the y direction, being the vertical direction, we know that the acceleration due to gravity will be 9.8. So negative 9.8 meters per second. We know that there is going to be no acceleration in the x direction. Okay, we are given that. We know that the acceleration being the initial, the initial velocity in the x direction is going to be the same as the final, because remember, it's going to be constant. Our velocity in the x direction is constant. But first off, let's deal with this very first value here, with the y direction. Let's deal with the up and down, the vertical motion, sorry. Let's figure out our initial velocity in the y direction. Let's figure that out first. We know that at 30 degrees to the horizontal, it's going 10 meters per second. So if we use a little bit of trig, so let's do, so to remind you what the trig functions are, we have so, ka, soa, being sine theta equals opposite over adjacent, cosine theta equals adjacent over the hypotenuse, hypotenuse here, and tan theta equals the opposite component over the adjacent component. Very good. So in this particular instance, if we put in our actual components, our resultant vector is 10 meters per second. we want to find out eventually what our horizontal vector is eventually. And right now we're going to solve for our vertical component, a vertical vector, a vertical component. It's going to be u. So let's change that to u. It's going to be the u, which is the initial velocity, because we start off with initial velocity of 10 meters per second uy, and it's got this angle theta 30 degrees. Awesome. So in order to get our opposite, so our opposite component being vy, okay, we need to say sine of theta, and let's just skip theta. We know sine of 30, okay, 30 degrees is the same as so the opposite being uy, initial velocity in the y direction, over our initial, so over our resultant over 10 meters per second. Beautiful. So if your calculator is in degrees, if you do sine 30, it's going to be 0.5. But if your calculator is in radians, you need to put, and I'll put it over here, if your calculator is in radians mode, you need to put sine of pi over 6, which is going to be the same thing. It's still going to be 0.5. Sine of 30 is going to be 0.5. So it's already put that in. Let's already know that. And we can rearrange it. If we put in this as 0.5, we could already put that in. So we know that u, the initial velocity in the y direction, uy, is equal to 10, put that in blue, so 10 times sine of 30, which we know as 10 times a half, which will just give us an initial vertical velocity of 5 meters per second. Awesome. Right, now let's have a look. Let's go down a little bit more here so that you won't get in the way of my video. Let's have a look now at the horizontal direction. And the horizontal direction, we can just simply use our Pythagorean theorem. It just makes it easier. So the resultant, okay, the resultant vector squared should equal both the components squared. So if we put this here, our final, okay, here, so if you think logically, our resultant initial velocity should equal our initial velocity in the y direction squared plus our that should be u, apologize, and our initial velocity in the x direction squared. So in order to get our initial velocity in the x direction, let me scroll down a little bit more. Our initial velocity in the x direction, not squared, should be the square root of our resultant initial velocity minus squared minus our initial velocity in the y direction squared. So if we do that math, it should end up being the square root of 10 squared minus 5 squared, which equals, let's scroll down a little bit more, sorry, we should equal square root of 100 minus 25, which is the same as the square root of 75 which should end up being, I believe, 8.66. Let's go over here. 8.66 meters per second. So we found out our horizontal velocity here. Now, this is going to be a constant value because we know that in the horizontal direction there's going to be no acceleration, so that 8.66 is going to be constant.